Good day, everyone. My name is Kyung Moon. I'm an industry analyst and mobile expert. We have a wonderful webinar prepared for you today. We have speakers from China Mobile, Comba Telecom, and Intel, along with myself. Just to start off, we'll be discussing about the tapping into the value the 5G distributed smart picocells bring to your network. To get our presentation started, I will go over a bit about the market. So as I mentioned, we'll be going over the 5G indoor market update from ourselves. So when you look at the 5G market, we have an expanding 5G networks and ecosystems. This chart is coming from the GSA. As you can see, we have over 200 operators that have launched 5G mobile services today. And there are over 1,000 commercially available 5G devices, ranging from smartphones to customer premise equipment for fixed wireless access applications, and many industrial routers and devices as enterprises and operators look to tap into the 5G value they can bring to the private wireless market. In addition to the increasing networks and ecosystem, we see this, the continuation of the mobile technology expanding the connectivity for mobile subscribers. This chart shows that we have, at the end of this year, we expect to have about 1 billion 5G connections, growing to over 4 billion 5G connections by 2027. As you can see, this is just a continuation of mobile technology creating a greater value for the society at large. In addition to mobile connections, we're seeing an increasing usage of 5G for fixed wireless applications as well. Obviously, compared to the mobile connection, it pales in comparison in terms of number of connections, but we ourselves are forecasting about almost 100 million 5G connections in the next 5 years. This is in addition to the LTE and 4G and the prior technology that has served this market, but with the increasing capabilities of 5G and additional spectrum that's coming available, we expect the 5G connections to continue to grow. In addition to the mobile connections and fixed wireless applications we talked about, there's an increasing interest and adoption of 5G and prior technologies such as 4G and the ones before in an enterprise context. From our perspective of the market, both the private wireless infrastructure and device equipment sales has continued to grow. I mean, this is in addition to other wireless technologies that serve the enterprise market. In our view is that the private LTE and 5G market, in terms of the equipment sales, represents about 10% today, and we expect that to increase its share over time as the overall market grows. Obviously, private cellular is not new, but it has been utilized in many critical applications, in critical infrastructure application, mining, and other critical industries. And we are seeing a digital transformation trend that's really looking at the private 5G and 5G for handling the business critical application that requires more deterministic characteristics as well as a high security measures. And it's making a, again, as mentioned, it's increasing share, and we're expecting a pretty exciting trend ahead. But obviously, bringing 5G indoors has its challenges, as we all know. As we're looking at 5G and the future technologies beyond, the spectrum availability, continues to rely in the higher band spectrum, such as the C-band and the millimeter wave band, as we think about, what's available to address the increasing number of applications and data traffic demands. As we look at the wider channel bandwidth, obviously requires a higher capacity backhaul or front haul applications and capabilities. So that is one challenge. The second challenge, lies around the modern buildings and materials that we use. As we look at modern tall buildings and low E glasses to really think about the environmental impacts, the outside in, the traditional method of addressing the indoor challenges of outside in becomes a little more challenging. It becomes a problematic, especially when we think about higher spectrum bands and address, being able to overcome this, energy efficient materials such as low E classes. And obviously, tall buildings and larger buildings, um, are hard to address. And the macros and the massive MIMO radios are obviously being used for the 5G and the future technologies. This becomes a problematic for addressing tall buildings and larger venues. So lastly, there are some challenges around the business models as well. As we think about bringing 5G signals indoors, there are multiple stakeholders. Obviously, operators play a huge role in bringing the 5G technology indoors, but also we have the building owners, or sometimes in a multi-tenant environments, you have a lot of different types of enterprise companies. So you have multiple stakeholders and the folks who actually deploy the network, such as system integrators. So there's questions around the business model questions around who owns the network, who operates the network, and who pays whom for that, bringing that technology indoors. And not to mention the ongoing management of the network indoors, whether it's for private use or public network services. So these are some of the key challenges that we see as we think about bringing 5G indoors. So as we look at the various types of venues out there, relying from very large, highly dense venues such as sporting stadiums or malls and airports, places where a lot of public people congregate. There are different types of applications being utilized in those venues as well. As we think about those, high density venues, large high density venues to, I would say, lower size venues, but may have a low density of people, such as like a warehousing environment where you don't have as many people working inside, especially those warehouses that are highly automated. There are different kinds of requirements, both from the amount of traffic that you need to handle, as well as the number of users and the volume of data that you need to consume. We see the market in a kind of very broad categories. When we say distributed antenna systems, we're talking about these are, highly capable, handling multiple spectrum bands across multiple carriers. Those what I'll call, full DAS type of systems have traditionally handled these large high density locations. Compared to the other extreme where you have a very low density traffic requirements, repeaters or signal boosters have addressed those smaller venues. In between, we're seeing an increasing use of small cells, such as the distributed picocell we'll be talking about. They provides a lot of flexibility and capabilities as operators look to bringing 5G signal indoors. So when we look at the market, there are different challenges as we talked about, from high dense locations to smaller low density locations. So we look at the market in two vectors. What is, by the size, how large the venue is, and the amount of traffic or the user density that you need to handle, from very low density locations like the warehouses we talked about, to very highly dense sporting stadiums, where, like, for example, World Cup is going to be held, places like that where you have just tons of consumers across multiple operators looking to handle or consume data at those locations. So when we look at the market, obviously we look at the market in a both single operator context to a multi-operator context. Multi-operator, we typically think of repeaters or signal boosters to, as I mentioned, very highly capable DAS systems. These are active DAS systems that are able to handle, multiple spectrum bands, as well as the large bandwidth that's required to handle multiple operators. To single operator solutions such as the small cells. You have, whether you talk about integrated small cell that can handle all-in-one integrated small cell that can handle smaller size of venues, to a distributed small cells that can handle a wide range of sizes as well as the capacity, because the fact that you have a distributed architecture, you can apply the capacity independently of the coverage, depending on how the small cell architecture is laid out. At other extreme, we have all-in-one integrated millimeter waves types of small cells. I know that's that's probably we see that coming in the future years. Not so much today. There's some deployment, but it's not widely pervasive. So when we look at the small cell market, we look into the past, what happened in the 4G era. Obviously in the early days of 4G era, we had a lot of innovative smartphones that really took the operators by surprise, some operators by surprise, in the sense that it created a tremendous amount of data usage. So operators were quickly transitioning to increase the network capacity, going from 2x2 macro radios to 4x4 to increase the capacity. And they were working also with the limited amounts of spectrum back then. And so when we look at the amount of data that was coming into the networks, femtocells, or being in a kind of residential context, or even some very smaller office SOHO type of a market, became a very popular solution to quickly address the tremendous amount of data that came in. So this chart's from our small cells tracker that we track the small cell market. When we look back into 2015 era, we saw more than 3/4 of the small cell shipments were of the residential variety or the femtocell variety to handle the traffic load. So as we look at the 5G era, we're tracking the market now, and you see a greater emphasis of 5G small cells, and as we talked about, the challenging outside-in strategy with the mid-band macros. We are seeing, not just because of those higher spectrum bands, but also the modern building materials we talked about. There's a greater need for highly capable 5G small cells that can handle wider channel bandwidth to handle the traffic load. And obviously, the consumer usage of the mobile data continues to go up. We find different levels of consumer consumption, but we're seeing a very high usage in China, high usage in other markets, in other developed markets. And obviously, this high data demand is really driving the infrastructure investments to really expand both the coverage and capacity of indoors. And there are higher enterprise deployments for 5G small cells here. So as with this chart is our kind of forecast of the market, and we expect greater demand for the indoor systems going in. So as we look at the small cell, there are different architectures we can deploy, but when we look at the distributed small cells, it provides a lot of flexibility in terms of scaling by the number of radio units and you can deploy, and with the context of the Open RAN or proprietary variety, you can apply the different capacity through the baseband function in a kind of an Open RAN architecture with the distributed and centralized units, leveraging kind of the off-the-shelf server architecture to increase the network capacity demand. So in summary, we see the 5G network deployments expanding to handle the increasing share of the connections. And there's a greater opportunities now with the FWA services and private 5G applications. And there are different indoor solutions handling the different both capacity and the coverage demands, ranging from small cells to DAS systems. And obviously the higher spectrum bands and the complex business models really demand a flexible solution. And we believe that distributed small cells offer that flexibility and the deployment options for both operators and enterprises. And obviously, the O-RAN compliant small cells offer added advantage of the open ecosystem, and we see that as being a tremendous value there. Okay, so with that, I would like to turn over to the next speaker, Junyu Chao from China Mobile. He will be speaking next. Thank you.
Hello, everyone. Hello, everyone. This is Jingyu, come from the CMCC. Uh, I'm feel very glad to have this opportunity to communication about 5G and 5G small cell. Appreciate Comba for organizing this webinar today. So, first of all, please allow me to the construction of China Mobile's 5G network. In terms of commercial 5G deployment, till now, we deployed more than 850,000 5G base stations covering 1 billion population. Connected 5G UE more than 300 million. It's about 21% of world market. In terms of network performance, our 5G network downlink throughput reached 1.7 gigabits PS at 100 megahertz bandwidth. Uplink throughput reached 3.15 gigabit per PS at 200 megahertz. So we have 1 gigabit PS super uplink and ultra low latency, about 6 to 7 millisecond. So the ultra reliability reach 99.999% and higher precision position down to the metro level. So we have five technology focus area from the innovation. They are wide coverage, advanced technology, extra silent performance, higher energy efficiency, and customization. Okay, so why we need a 5G small cell? By our a lot of work, we think a high frequency spectrum used for next generation wireless network. Uh, the traditional DAS is capacity and frequency limited. So we believe 5G small cell is a future. From the public network to say, outside in approach from the micro cell does not able to fulfill indoor coverage requirement. But the traffic are mostly generated from the indoor. So small cell is a long-term solution to address increasing data demand. Another side from the pro provide network, we need a convergency, small cell, add edge cloud, add core network, add MEC, add UPF, and the local integrated platform. So we believe uh, very huge potential in the 5G enterprise market in the future. Strong demand of flexible 5G networking from the manufacturer, meaning care sector, enterprise network has potential demand involved millions of radios. It took customization to fulfill requirement in the segment enterprise market. We believe the Cloud RAN, the O-RAN, Open RAN kinds of architecture product address the customization, flexible, and agent deployment in a cost efficiency way. So based on above a lot of reason, this year China Mobile completed the 5G small cell purchase. We are purchase two kinds of type small cell. One is 2T2R single mode. Another is 2T2R dual mode LTE at 5G NR. So totally, we purchased 20,000 small cell, and the plan, the small cell will deploy since next year. So another some information show China Telecom and China Unicom plan purchase 5G small cell too in this year. So I want to say, but we 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 have some challenge. What's the challenge in the development of 5G small cell? Um, I think at least the 3 point. The first one is how to ensure smooth implementation and QNM in the large scale deployment. How the second one is how to ensure the sustainability of small cell development. The third is how to create additional value from the 5G connection. How to do it? Summarize, we have a 3 way. The first one is we plan making mature product with brownfield try by conducting multiple round of trial in brownfield. We continuously optimize the product, service, and the Q&M process. We will give small cell enough time to enhance uplife customer recognition. The first way. The second way, we are continue try best on the extend the value of 5G connectivity, build a smart industry application with complete ecosystem. This ecosystem, we believe, the cloud runs, all run, open run, looks like this architecture and ecosystem is key. The last way, that is, we believe in the future, we need to build a network and cloud and computing all-in-one solution. Use by this solution to address industry vertical three wireless network service. We in the future, the way is build wireless connectivity and computing and diversity on O-RAN or Cloud RAN. So the key advantage we believe is uh, the Cloud RAN believes high performance computing and deterministic networking. So that is our way to meet the three challenge. That is all of my today's communication contact. Thank you.
Thank you, Junyu. So next speaker will be Jan Berkland, Senior Director of Product and Solutions from Comba Telecom. Jan, take it away.
Thank you, Kyung. Let me get my slide deck up. All right, so this is what we will be talking about today, the Comba 5G distributed picocells. Oops. All right, so what I will be covering today is the story behind the Comba distributed small cell solution and how it can be deployed and used in the real network scenarios. So without further ado, I'll step in right into the solution. Comba's radio solution portfolio covers many solutions for different deployment scenarios. We will talk here today about the distributed small cell that we call iCell. For us, this is an important part of the solution portfolio. We position it as a primary tool to provide enterprise customers with coverage, both for public and private networks. This is a scenario that is not easily served by the other solutions in the portfolio. While they can overlap, it is a very specific segment, as shown in the previous presentations here. All right, so let's talk about the solution. What you see here are the three main components of the solution: a low power 44R radio, switches, and then the baseband unit. We call these ones AU, switch, and DPU. It will all make much more sense when I step into the architecture around this. All right, so let me explain further. When we took on this challenge to make a new platform to address enterprise coverage, we had a few design key goals that landed us in this architecture. One was designed for flexibility, so both in terms of area coverage, but also capacity. We also wanted to have a more centralized processing approach to this. And this is mostly for flexibility, but also for cost, to drive down the cost of this equipment. The third one was a much more software-based model than we used in the past. So we wanted to improve time to market for new features, also make it more flexible to sort of integrate different parts that were unknown to us at the beginning of our journey here. So if you look at across this sort of functional split that we have shown on this slide, you have these three components that I mentioned: the access unit being the baseband processing, you have a switch there for aggregation and power supply to the distribution points, the distribution points being the radio function in this. As you see here, this is not only a 5G solution, it is capable of running 4G and 5G. Apart from being a very cost-efficient architecture for coverage, one of the most striking things about this architecture, it features this flexibility in network capacity without hardware changes. So once coverage has been designed, one can easily change capacity to where you actually need it, and this by enabling more cells with existing radios. This makes it very cost efficient to address a large variety of scenarios, from full coverage with very thin capacity to full coverage with very high capacity, as well as designed for a wide range of user densities. All of this is good for the different type of vertical industries this tries to approach. So we have all kinds of different scenarios for this in the background. All of this by just reconfiguring or adding cell capacity at that central location that this offers. All right, let's talk a little bit about the use cases and some of the examples that we have around here. But maybe first, I'd like to before I do the introduction to these use cases, I'd like to highlight some of the cooperation that we had with China Mobile and the learning process around this. So Comba has worked with China Mobile for years on these concepts, creating a solution to target this market. Through this, we had the opportunity to gain insight and knowledge to the use cases. And as you can see here, we also had the opportunity to have our solutions tested, not only with China Mobile Lab, but also, last but not the least, build some of the world's first industrial 5G projects together with them. So let's take a look at the first case here. So within the framework, we have done several of these projects to create coverage, like this restaurant example, for instance. For those that have not been in China, some of the Chinese restaurants can be quite large. This one is more than 5,000 square meters and capable of hosting 700 guests. And of course, if you would try to address this with outside in, it has its challenges and it's more than challenging. So for this project, we used 19 radius distribution points with both LTE and 5G service for the benefits of the guest, with excellent results. This is another example. This is the mining project that we did, where mining operation was monitored and controlled remotely to improve safety and enhance operational efficiency. For this project, Comba supplied not only the RAN, but also CPE equipment and the core. Mining is a very capital-intensive investment. Therefore, you need very reliable operation. There are two unique features that stand out in this project. The first one is we actually used two separate 5G cores, one above ground and one below ground, to ensure that we at all times have uninterrupted operation. The second one is a specialized CPE that meets mining safety standards. We were required to build this one to be able to enable the mining equipment underground. So this is the last of the cases that I have here that I will present. So this is the Smart Factory project. This we first tried out in our own manufacturing base in Comba. So with this project, we aimed at automating the manufacturing plant using 5G as a sort of transformational tool. In this project, we did a number of sort of first in our factory. We 5G enabled the automatic guided vehicles so we could control them. We introduced cloud-based machine visual inspection for quality control. So 5G enabled cameras going to cloud and inspecting the products that are coming out. We also have ultra-wideband tags for positioning of goods in the plant so that we can do a proper planning. We also did some interesting things on the factory floor with augmented reality. So when the engineers on the factory floor finds anomalies in the manufacturing process that they can't explain, they can now easily consult some R&D engineers for further advice by taking them online, seeing the things that they do, and at the same time then see what they should be doing to maybe tune filters and other things. We even connected the cloud-based face recognition system to enhance safety and security in the manufacturing environment. We did not do all of these things alone. Comba partnered with a number of local companies for applications to put on our mobile edge core for the individual use cases in the factory. So last, I'd like to talk a little bit about our partnership with Intel. Throughout the development of the iCell solution, we partnered with Intel. In 2018, Comba studied a number of different concepts to see what would best fit the solution design. And eventually we selected Intel. Intel offered at that time a time to market advantage versus the alternatives. A very deep cooperation, both on technology and business, that we highly valued, and an advanced roadmap that fitted our vision of the architecture. It also enabled Comba to maybe go beyond some of the initial ideas that we had and create interesting new solutions, such as combining RAN and core products within, or RAN and core functions within inside the same product, but also opening up for third-party integration. With that, I'd like to hand over to the next speaker.
Thank you, Jan. The next speaker would be Wei-Yang To from Intel. He's the General Manager of Ecosystem Development. Wei-Yang.
Thank you. And let me flip my slide. All right. Hey, thanks for having me today here. And I hope that you guys can hear me well. As we transition into a 5G era, we constantly offer more opportunity for our ecosystem to tap into new value of 5G. The level of innovation across the network and edge is truly amazing, and it's only going to continue the journeys in the next few years. Our industry are going through a very significant digital transformation, and we are seeing this happen in nearly every sectors. In areas like retail, hospitality, manufacturing, energy, education, and even entire cities. And we all know the potential benefit of this digital transformation. It offers a new operational efficiency, a new monetization opportunity, and ultimately a better business outcome. At the same time, we are very aware that you as a customer are facing big challenges as you try to automate your infrastructure and deliver a new type of use cases, whether it's factory detection, AR, VR assisted maintenance, a personalized customer shopping experience, and secure infrastructure to support online learning and remote workforce. This is where AI, edge computing, enhanced connectivity, and truly edge to cloud infrastructure can have a transformation impact. If we take small cell as an example, small cell is vital to expand 5G network coverage for a specific space. Small cell will use less power to provide high-speed 5G access for smaller area, very concentrated area. The key use cases that require critical real-time, ultra broadbands, and support massive IoT devices able to benefit from private wireless implementation along with the 5G small cell. There's simply a list of the benefit, including faster deployment rate, more cost-effective, improved data rate, better network capacity and coverage, better security, and vertical use cases integration. All those will bring both technology together under one roof to serve our customer needs. Intel is excited to be a trusted partner on this journey and help you and your customer to take your business to the next height. Our approach from Intel is to understand across different vertical industrial sector challenges and what they need the most to solve the problem. We develop the silicon platform, the software, including optimizing and contributing to the open source community, and then ultimately work with our ecosystem partners to deliver those solutions to the industry and connect those industry sectors and users together. It could be manufacturer, it could be retailer, it could be healthcare provider, and many more to see the possibility that they could extract out from Intel and our partner solution like Comba. Let me give you one example of real solution where Intel is providing our platforms, our software with our ecosystem partner together in CD and transportation sector. We all know how busy a CD is, and CD is constantly looking for a way to streamline the traffic flow, reduce emissions, and improve the commuter experience, looking for a way to implementing a smarter city, a more intelligent transportation system. One of our key ecosystem partners is transforming the modern city with Intel-based architecture to build a smart roadside unit, and that could integrate with a small cell from Comba as well. By bringing together the Xeon D platform, our distribution of OpenVINO toolkits, FlexRAN software stack, and Smart Edge Open, our partner could develop a smart RSU, which stands for roadside unit, to enable the intelligent transportation application like traffic management, EV charging, smart lighting, connected vehicles services, and placing all those computing at the right location at the network edge. This helps to reduce the network latency and processing time. As a result, the vehicle and pedestrian detection during the busy intersection will be more seamless by using the 5G connected camera feed and AI to optimize the traffic flow. This helps to identify and warn the pedestrian and the drivers of the potential collisions and allow the city traffic controllers to be able to dynamically establish a better green light corridors for any of the emergency vehicle. So simply there are more benefits here by implementing the solution. Intel processor and technology are enabling our ecosystem partners to deliver a fully programmable cloud to edge infrastructure. And this covers whether in cloud data center, core network, network edge, or devices and think. Our ecosystem will enjoy a scalable architecture by utilizing Intel processor and platform. And our open source and developer tools will offer consistent development environment and easier solution readiness integration. Our ecosystem program marketplace are filled with a list of innovative solutions across different vertical industry and help to accelerate the market adoption needs. As a closing, I would like to bring you home with what you can expect from Intel and our ecosystem partner. We embrace the power of open. We make it easier for ecosystem partner to innovate on the open architectures like Intel platform. We offer greater choice. We are providing more options across silicon software and platform to design for multi-vendors, multi-cloud solution. And we act with your best interest in mind. Our ecosystem partner utilizing Intel market-ready portfolio to deliver solution with more sustainable, scalable, and leading security features. With that, thank you for your time, and we appreciate your partnership. And pass it back to you.
Thank you, Wei Yang. That was a very good presentation. With that, I want to ask the speakers to turn on your cameras and microphone. I'd love to have a panel discussion on the topics that we just talked about. And I would like to encourage the audience members who are on this webinar to type in your questions, and we would like to address them as the best we can. So feel free to. And we already have some already in the queue, so I want to ask our panelists here. Just to kick off, those are all very good insights that you presented to our audience here today. I want to pose this question to Wei Yang. You gave us a very good perspective of Intel's view and how you're developing the ecosystem for the broader industry community here. What do you see, because you work with a lot of different partners, what do you see as the primary use cases and applications driving the 5G indoors deployments?
Thank you. Thank you for the questions. If we look across a 5G indoor, it have to support in fact many use cases. But if we bring it down to a very focus of the technology domain, in fact we can look across three domain. Number one, the area that requires a critical real time with ultra reliability, low latency, and high availability. The second one will be the one that requires ultra speed mobile broadband usage that, for example, enhanced video experience, enhanced multimedia experience. And lastly, the one that requires uninterrupted coverage for massive number of devices, but non-real-time data, right? Just massive, right? So example for critical real-time use cases will be things like mixed reality for mission critical use cases in manufacturing to do a remote troubleshooting, the remote diagnosis for healthcare, robotics, all those are mission criticals. High-speed broadband, the classic use cases will be like entertainment for user experience. And while massive number of devices will be like IoT application, which is within the building itself, you have like massive devices with sensors tracking. And all those will simply benefit out from the 5G indoors with implementation method as small cell.
Great, thank you. This is a question maybe is I'm sure a lot of people are wanting to know. This is for Jen Yu from China Mobile. I'm just curious, why did China Mobile choose the Comba solution and the distributed architecture specifically? Jen Yu? Jen Yu, can you hear us? Okay, while we wait for Jen Yu to come back to join us, I want to ask this question to Jan, if you could. What are some of the key decision factors that you should think about in choosing the distributed small cell architecture? And there's a related questions around how does this is questions around the kind of the split option. There was one audience question to Regan, what is the kind of optimal split option as the one thinks about the distributed architecture choice, whether it's a split 7.2 or split 2. Can you give us some commentary there?
All right. Okay, that question I think has many aspects to it. Where should I start? Maybe I start in sort of the architectural point of this, and I come back to the split option towards the end of it, right? So, as I sort of demonstrated or tried to demonstrate through my slides, we're looking at this sort of distributed small cells from the benefits it would have in these specific scenarios. Now we are talking about a quite large sort of chunk of business here. I mean, as Wei Yang pointed out, there's quite a lot of difference between the different industries that needs to use these solutions, and I see it as sort of scalability in terms of coverage, the capacity of things, number of users that you need to have. And this type of solution is specifically targeted to have that flexibility, as opposed to if you sort of compare to some of the traditional solutions that have been there out there in the past, right? If you take a repeater solution, it's cheap, it's simple to deploy. You don't have to do anything with anyone to sort of make it work in a way. No interaction with the operator. But then you have the other ones as well. I mean, maybe some of the integrated cells that I think was China Mobile brought them up as well. Yeah, they've been there in the past, right? But they have their own shortcomings in terms of number of devices that can be connected and the sort of manageability aspect of this. They have their place where they glow, and I mean, it's, as you pointed out, and also with the first part of your presentation, you do femtocells, yeah, all right, and that is the most cost-effective one to do there. DAS has its own sort of point where those type of solutions fit in as well, where you have sort of multi-operator, multi-rat, and all this complexity from the past, right? Where it fits. But when it comes to distributed small cells, especially for this enterprise coverage, much of the sort of past, we look at legacy technologies, is not there. What is needed is 4G and 5G, and it's robust communication. And this is where it shines. This is where that architecture makes most out of it. All right, coming back to the split question, then there's split 2 versus sort of split 7-2 and things like that. These systems, at least when we work with China Mobile, we design them to cost. And this is also why we worked with Intel in this case, right? So the most important thing is that it has a cost structure to add these new segments. I mean, we had DAS in the past. It's done its specific niche out there. So it does these airports, it does these sort of big installations. You have the integrated small cell, does its specific piece of it. But this enterprise space has been largely sort of not addressed, and partly it's because it's not been a cost-efficient solution to do this. So the whole purpose is to bring this down in cost. And to do that, it is more a split 2 type of thing. Now, we interface here with sort of an S1 and NG interface towards the core from the radio solution piece of it. So it's, well, okay, it's a little bit short of, or add to this split 2. But inside the system, what one tries to do is just minimize the cost in those boxes that needs to be repeated again and again and again, like the radios. They need to be able to perform all the functions, but you don't want to have this sort of over complexity out there.
Yeah, it's definitely the simplicity is an important factor, right?
Yes, simplicity is important, not only for sort of how you design it, but for cost and how you manage it as well. That's management aspect is China Mobile brought up here a few times. The O&M aspect of it needs to be centralized. These are the sort of design points that we use when we work with them to bring out this concept.
Yeah, there's an audience question specifically around one of your slides, Jan. Before I go to Wei Yang, what is the interoperability, the Comba? You talked about the private smart mining and industry, and you talked about the separate core. How does the interoperability happen with the legacy 5G core vendor solutions there?
All right, so in that specific case, we actually shipped, it was a complete Comba end-to-end solution with Comba Core, with Comba RAN, with Comba CPE, because of the nature of that specific deployment. But having said that, we have made this solution interoperable with all the sort of major tier 1 cores that you have out there and some of the tier 2s as well. So that interoperability is there day one when we start with this. Also with China Mobile, when we connect this, it's not, the normal case is not to our own core, it is to whatever core they have in that province, which is different province by province.
Right, okay. I'm just going to, we have a few questions here specifically for Jin Yu. I know he's having some technical difficulty. He was trying to join us as soon as possible. But before that happens, Wei Yang, I'm going to address the question to you. What do you see, what advantage do you see with the distributed small cell? We kind of touched upon it, but maybe you could help emphasize that in terms of how that applies to the private wireless deployments.
Yeah, sure, thanks. Yeah, I touched on that just now as well during my presentation. So small cell is really vital to help to expand the whole 5G network coverage. As we see today, what's happening in the market, a operator is rolling out 5G coverage as first phase, right? All the sub-6, they go wide coverage. They are the typical user like you and me, say holding a mobile phone, commute around the cities, right? We need coverage. While the small cell, while the 5G need to penetrate across a many malls, area footprint is critical to expand our 5G network coverage for a very specific space. And we're talking about utilizing a technology that able to not only use less power, right? So we know 5G will require a high power. Small cell will give us a more concentrate footprint coverage with less powers to provide the high-speed 5G access to that particular area, right? So it's concentrate, it's go with purpose. Key use cases that requires critical real-time, ultra broadband, massive IoT devices support. We're able to benefit out from a private networks implementation with small cell, right? That come again a very specific cater for the one area's needs and the customer needs as well. Faster deployments, more cost effective, right? Improved data rate, network capacity coverage, and better security, more secure, right? Versus the typical Wi-Fi, right? And it could even go one step further for a deeper vertical use cases integration, right? Simply it bring more together, under one roof, right? I see this as a huge opportunity for the more ecosystem come in and participate in the market space itself.
Great, thank you. I know this is we can't speak for Jinyu or China Mobile here, but just maybe we could get perspective from Jan from a vendor perspective. There's an interesting question from one of the audience members talking about is 5G small cell preferable solution compared to 5G macro, right? In the context of China Mobile or any operator. Love to get vendor. I'm sure you have your perspective. Maybe you could share that. Hopefully, while you're giving your answers, we have Jinyu join us to give his perspective there.
All right.
Yeah.
So, absolutely. I think you can't have only one or the other one. I think maybe that would be the preference from some vendors that you only have one solution, and that's all what you need to do. But I think it's become more and more evident, and the whole thing that you consume much more data indoors. I mean, if you look at the public space, sort of pushes this. You need to get the signal indoor somehow, and then getting from outside in. Well, I think in at least most Western places is very difficult to get more sites, so you're blocked by that. Yet I think it's become almost like a utility or necessity for some businesses. If you're going to rent a new business property, yes, you would check that you have the water there, and you would check that you would have heating. But I think today also you would check that you have coverage. No coverage, and you will probably be no rent. I'm not interested at all. So that has become extremely sort of important from that aspect of it.
Yeah, that's a very good insight. I know we had a glimpse of Jinyu, and
Yeah,
there he is.
we have...
Jinyu, can you hear us?
Yeah. I can hear you. Sorry.
So I'm glad. Yes, we can hear you fine.
Okay.
One of the questions before you left, we're going to ask, why did China Mobile choose Comba solution, the distributed small cell solution?
Well, yeah, we think the first one. Firstly, thank you for this question. I think two reasons. First one is extra silence performance of the Comba's product in our SAMCC lab testing. That is very good. The second one is we also considering Comba is the most powerful expansion vendor in China small cell ecosystem. So the Comba's delivery and operation and maintenance capability is very good. So in this year's MCC bidding, Comba won the largest share of small cell. Yeah.
I see.
Thank you.
There's also, before you join, Jan gave his perspective, and really this question was really for you. And the question comes from one of the audience members asking, is 5G small cell preferable solution as compared to 5G macro site for China Mobile? And we heard from Jan, but we'd love to hear from you directly. Can you comment on that? In other words, would you prefer to deploy 5G small cell indoors as compared to having a 5G macro site perhaps
Yeah,
nearby?
the plan is maybe since from next year. Yeah, deploy
Okay,
the 5G small cell. Yeah.
very good.
Mhm.
Okay. And this is maybe a question for Wei Yang. I just want to get maybe going back. I know you talked about we talked about obviously public service, public cellular services that's enabled with 5G indoor solution, distributed picocells. I want to get your, Wei Yang, your perspective on what is a role for you? What role do you see operators and enterprises and vendors play in private wireless deployment? Obviously, we're going to continue to make investment for public services, but there's this adjacent opportunity with the private wireless deployments. And what role do you see the different stakeholders playing, the operators and vendors and enterprises?
Yeah. Hey, thanks. Yeah. Hey, so for operators here, obviously, is to embrace a small cell architecture, right? As Jan pointed out, there's no one size fit all, right? There will be macro, right? Macro go first, provide coverage, right? And for user that requires multi-tenancy services that they could accept the service level agreement is totally fine, right? But then there will be a lot of areas that will require say a small cell coverage, right? This is where we do see operator lean in, right? Embracing the small cell architectures, working with the partners to select the best solution that fit their needs. For enterprise is to think about how would the 5G and particularly small cell technology and private network will help to accelerate their digital transformation by combining the CT, which is communication, and the OT, right, the operations technology together in order to improve the operation efficiency and create more business value. This have to be part of the top agendas to help the enterprise to go through the digital transformation. And then for the vendor is really able to provide a wide selection of solution, but with consistency of experience right, across the scalable architectures and make it really simple, right, to consume the technology. And if we put all those three together, right, the among the three party here today is right across operators, the end user and vendor, it simply will help us to move the market adoptions here faster together.
I know we had a comment. We are at the top of the hour, but just want to give a Jinyu the comment opportunity to answer the previous question about the 5G small cell, whether that's preferable to macro.
Yeah. So sorry, I just maybe the signal issue. I have not get your question. Yeah. So as I just the presentation to say we think in the indoor scenario, the outside in approach from the microcell very difficult to fulfill the indoor coverage scenario. So we think the for the indoor scenario, the small cell is a very good solution. Yeah, prefers microcell. Yeah, that is.
Great. Thank you very much for answering that question. And with that, we're at the top of the hour. So thank you for all the speakers and thank you for all of you joining us. There are some questions we didn't get a chance to answer, so we will follow it up with the email. Again, we thank you for your attendance today. Have a great day. Thank you. Bye-bye.